I will first demonstrate how to create namespace and where the namespace is mentioned in the config file. So we are actually getting started with it, and then we'll go for the theoretical lecture. Okay, in the meanwhile, let me start session 8, Kubernetes namespaces. What you will learn in this session is what are namespaces, how to create namespaces, working with namespaces, and the labels, selectors, and annotations. Namespace. The first useful tool for managing access to resources in your cluster is the namespaces. Namespaces allow you to subdivide a single physical cluster into several virtual clusters, each of which look like original but is completely isolated from other clusters. One of these virtual cluster is called a namespace. Look at this example, which will make the concept more clear. This is a whole physical cluster with outside boundary. The Kubernetes cluster, this is the team which is managing everything, all the nodes and user accounts and everything. When inside that we have a red team which is managing only specific service accounts with specific resource quota, the pods, the services, deployments, and these type of resources. There's another namespace with say green team which is managing everything in another setup for deployment, volumes, configuration, pods, and service accounts. So we are talking about three teams here. So this is one namespace, the global namespace or cluster wide, or the system namespace. Then this is another namespace. So this is a grouping of resources is done using by means of namespaces. Why do we divide it like this? What is the purpose of the namespaces? You can define resource limits on each namespace, which prevent users in that namespace from exceeding CPU, disk, or object limits. Namespaces also isolate resources, which means that resource created by one team in your company won't be affected by resources created by a different team. Of course, with the rights or permissions on that namespace. Namespaces may not be necessary if you are learning Kubernetes locally or for learning purpose only. It is required in production level scenarios. If you use namespace very rarely or you want to be explicit when using them, then with your kubectl command you append this parameter hyphen namespace equal to namespace name, or simply hyphen n is equal to namespace name, hyphen n, that is namespace, equal to the namespace name to the kubectl command you are executing. This is a simple, explicit, and easy to remember approach. However, if you have a requirement where you always have to work in a given namespace only, a specific namespace only, and you don't want to append this every time, so that means you can set this permanently in your kubeconfig file. Another option is to save the namespace in kubectl context of your kubectl configuration file, done by executing kubectl config set context name, and namespace is namespace name. So this is the command kubectl config, and then what do you want to do? You want to set the context, what context name and under what namespace. You can directly edit the kubeconfig file, but that's not the right approach to do it, because this line is going to make changes in the kubeconfig file only. This could be the right approach for you if you are frequently switching kubectl context and have different namespace names depending on the context. Now it is the time to go through this kubeconfig file and to create a namespace. First of all, let's understand some few more concepts before I proceed. Upon deploying your Kubernetes cluster, you will find at least three basic namespaces: default, kubesystem, and kubepublic. Even this is not mandatory. I noticed that I found only these two. default and kube system. Default is when you don't want to specify any namespace with kubectl command. Then the deployment will go to this namespace default. So use for deployment not given a namespace. Kube system is for everything related to the Kubernetes cluster. Kube public is readable by everyone but reserved for system use only. How do we create it? kubectl create namespace namespace name. This kubectl command will report back that namespace has been created, something like this namespace created. You can create a YML file also and apply it just like any other Kubernetes manifest file. Kind, namespace, API version, metadata, and labels. This is indentation is wrong here. Metadata, this has to be indented, and the label, this label has to be indented inward. So the point is this has to be very careful. This indentation is almost correct. It appears to be slightly incorrect. But I don't know if this N is under M or not. If this M and N are at the same level, then this is wrong. This N has to be little inside. And then apply this file. Let's create names. I'm working on this. Let's see the status now. kubectl get pods -o wide -. So all the pods are running. So everything is good in my case. Now I can check what all namespaces I have. kubectl get ns, that will be sufficient. So you can see that all the namespaces, default namespaces, kubeflannel, kube node leads, kube public, kube system, kubernetes dashboard, these are the namespaces on my system. If I want to create a namespace, I can use kubectl create namespace, let's say ns oracle. The namespace will be created. Now if I use get ns, I'll see the ns oracle also. And the next point, important point, is where the changes are made when you set this namespace as default namespace. For that you can go to .kube directory. Under that the file config file, you will see everything related to your cluster. API version, clusters, this is a cluster server name, context. So these are the context I was talking about. Cluster is Kubernetes, user is Kubernetes admin, name is this. Current context Kubernetes admin, Kubernetes, kind is config. So you see the context and details here about your cluster. All right. So when you set that, it will set the current context also when it comes to that namespace. So namespace can also be configured here. So that we will see in the command line also. So this is how we create the namespaces. Say you want to deploy Nginx pod to a new staging namespace. For that you will issue the command kubectl run Nginx, image is Nginx, and namespace is your new namespace what you have created. So the Nginx will be deployed in this namespace. A simple YML file to create a pod. Of course, we'll go into the detail into the session related to the pod, which will come after the tea break. So vi my pod. So this is the pod create manifest file. API version, kind, metadata, name is my pod, label. This is what I was talking about. Label and label selectors. Name is the key. You can give any key, donkey, monkey, horse. Only just you have to specify a key name followed by the value. And specifications, containers, name, image. You might notice that there is no mention of namespace anywhere in the YML file. However, that is possible because we are specifying the namespace in the command line while applying it. So if you don't specify namespace in the YML file and you don't specify that in the command line, in that case the pod will go to the default namespace. If you run kubectl apply on this file, it will create the pod in the current active namespace, whatever it is, which is by default is default. This will be the default namespace unless you change it. Deploy pods to a namespace. There are two ways to explicitly tell Kubernetes in which namespace you want to create your resource. So one way is to set the namespace flag when creating it, like kubectl apply -f file name and then namespace equal to ns oracle. You can also specify the namespace in the YML file itself, the manifest itself, like here, metadata, name, namespace, and labels. So here you are specifying where this pod will be created. If you have created a namespace and you intend to always use it as your default, that is also possible. Instead of having to use hyphen namespace equal to option in your deployment management commands, you could always set that new namespace as the default. For example, kubectl config set context current namespace is ns oracle. That is also possible. So that will be the default. Always that namespace will become the default. Let's try this command and let's see where the changes will be made when you execute this kubectl config set context current namespace is ns oracle. And now let's see what is displayed, where the namespace has been configured. See here, context cluster namespace, and this is the namespace entry. So this could have been manually done, because that command has done this change. And that's the so you never added the file directly, never ever recommended even. But however, just for to have the confidence, you can always check this. To list all the namespaces available, you can execute the command get namespaces. I demonstrated this command, I'm sure you know. To check which default namespace, you can use the command kubectl config view minify and grab namespace. That will show you the current namespace. Check with Kubernetes which Kubernetes resources are namespaced. Not all Kubernetes names resources are namespaced. There are some resources which are not namespaced. So means which are global in nature. So the resources which are namespaced are these bindings. It is namespaced, yes. Config maps, endpoints, event, limit ranges, persistent volume claims, pods, pod templates, replica controllers, resource quotas, secrets, service accounts, services. All these are namespaced because we specify kubectl API resources namespaced equal to true. When you give this command, you will say this, and what is the kind for them? These are the kinds. Kind means the what you specify in the manifest file. To see which Kubernetes resource are not in a namespace, use this command kubectl API resources namespace is false. So these resources are not namespaced, like namespaces themselves are not, nodes are not, persistent volumes are not. Persistent volume claims are, but not persistent volumes. Then API services, token views, these are not namespaced. List details, I mean get the more details, comprehensive details about a namespace. To list all the namespaces available in the Kubernetes cluster, you can use kubectl get namespace. Then to get details about the namespace using the command, you can use describe namespace, namespace name. Deleting is quite simple, kubectl delete namespace, namespace name. Labels. As I explained in the previous session briefly, but this is a actual concept, labels and selectors now onward in the session. Will be very important, will play a very vital role in the remaining sessions, because you will be focusing on these areas when you will have related resources like deployment, replica sets, services, pods. This part will bind the things together. So loose coupling or the coupling will be done by labels and selectors. So we need to understand this very well. Kubernetes let you associate key value pairs to objects to help you identify and query them later. These key value pairs are called labels. They are vital for grouping objects in Kubernetes. For example, if you want to group pods together into a service, you need labels and a label selector. Set labels for an object inside labels dictionary in the object's metadata property. Like dictionary entries in programming language, Kubernetes label consists of both a key and a value. Like this. API version, kind is pod, Metadata, name is my pod, and these are the labels. Label, release is stable, environment development, tier backend, region US. As I said, these are all keys you have created, you have defined. So these are the key value pairs you have created. So donkey, monkey, horse, cat, you can give any key with any specific value. But then you have to remember these keys and the corresponding values for binding them with other resources like services and deployments. Labels are meant to specify small specific properties of an object, such as its release stream or which layer of the application it fits in. They will be indexed and tracked by Kubernetes for querying, sorting, and filtering. Keep them short and sharp. View labels for a source by appending show labels argument to kubectl get command. For example, kubectl get all show labels. It will list all objects in the Kubernetes including their associated labels. Like kubectl get all show labels. So this will show that your pod is running and this was the labels in that pod. You may wonder that why it is showing only one. How can we have only one resource? Because you have not appended the namespace. Either you say all namespaces or specific namespace with -n, and if you don't specify, you know what does it mean. It means you are getting from the current namespace only, the default namespace only. Selectors. Selectors are the counterpart to labels that makes labels useful. They are the mechanism for performing queries based on objects labels. Selectors let you select a group of objects based on the key value pairs that have been set as their labels. You can think of selectors as where part of your select query, something like select a star from pods where label equal to value. You use label selectors from command line or in the objects YML when it needs to select other objects. Querying on the command line, even that is possible. To query objects in Kubernetes based on their labels, use -l or -- selector argument followed by your label query. Label queries specify a key and a value to use for the matching objects. You can query for things that have the value equal to operator or things that do not have that value that is not equal to operator. Combine multiple filters using comma, like which is AND. Label query can filter on set of values using in, not in, exist keywords. See this, kubectl get all selector equal to provider is Kubernetes or provider is not equal to Kubernetes or provider is Kubernetes component is API server or provider in Kubernetes util or mail. All these are valid queries for Kubernetes. Selectors in YML file, in the manifest file. For application developers, there are two important uses of label selectors, one in services and second in deployments. And you will realize it in our training because we'll be using services, we'll be creating services, managing services, understanding services, and also we'll be working with deployments. One of the most common use of labels in selector is to group pods into a service. The selector field in a service spec defines which pod receive request sent to that service. The service runs a query using the key value label pairs specified in this field to find the pods it can use. If the pods labels are incorrectly defined, your service won't send traffic to that correct pod. So therefore, this is the main reason for this is the main way to send the traffic to the right pod. You specify labels in the pod or the deployment, and then you specify the same selector in the YML file for the service object. See how it is created here. In the example, service will route the request to the pod that has the key equal to value and key 2 equal to value 2. See here, name my service specification. Now here the selector, and this is the query where clause I was talking about. Selector is key equal to value and key 2 equal to value 2. That can be done at the command line also. Using the command line, it is equivalent to saying kubectl get pods where selector key equal to value and key 2 equal to value 2. So these queries are crucial in working with Kubernetes. The selectors and labels play a very important role. You cannot ignore them. Annotation can be ignored. It is comments. It is the metadata, general information will be ignored. It will not be passed. So labels have and selectors have some functional purpose, but annotation is nothing for that purpose. What if you just want to store the detailed non-identifying metadata about your objects? Then you can use annotations. There are also key value pairs. However, annotations won't be indexed or queried on, and they will never be used to identify your objects. They are not for that purpose. Annotations can store large amount of data potentially in a structured format. Only the purpose here is the version number, contributor list, contact details, short release descriptions, link to logs, dashboard, and debugging information. Meaning, as I said, comments for a programmer. Look at the annotations. Annotation, commit number, log location, contact person. So this is how I can use annotations in my manifest files. That's all for this session. Thank you very much.